Well, hello everyone, and good evening, good afternoon, and good morning. So, this is your girl Audrey from ACG Math Tutoring coming to you live and direct for another part of probability. So, this time we're doing the probability of compound events. So, yesterday we were working on simple events. So, if something happens once, then you have over the total amount of times that that event is going to occur. But what happens if we got more than one thing that's going on all at the same time? So we're looking at some sample spaces with those complex. So right here, we're going to have a tree diagram to the right. So that tree diagram, let me scooch over. Okay, shows all the different outcomes of a team playing 3 games. So we need to complete the list of outcomes and then use that sample space to find the probabilities for the compound event. All right, so if we're taking a look, let me zoom in. Zoop. All right, so when we're zooming in, we have basically 2 situations that happens in games. Either you're going to win or you're going to lose, okay? So, but then when it comes to game 2, you either were in the winning circle or the losing circle. And the same thing if you were in the winning circle or the losing circle. And the same thing if you so you lost this one, so it puts you in a different bracket. So if you win, that means you have a chance to go to game 3. You're either going to win or you're going to lose. Or if you lose, they give you the opportunity to kind of go like a round robin type thing. So first thing that we need is to figure out what would be our outcomes. So if we take a look, we have a win, win, win type of situation. But then if we just go with a win to win, we also could have a win, win, loss, right? So say you won the first game, you win the second game, you played, and guess what? You lost the third game. So now what happens if you win the first game, you lose the second game, there's an opportunity for you to win the third game. Or you win the first game, you lose the second game, and then you lose the third game. All right? So that's what's happening with if you win the first one, you have opportunities of either winning or losing the second game, and then depending on your branches, if you're going to win or lose the third game. So now that's your wins. What happens if we start off with a loss? Okay? So we lost the first game. The second game, let's say we won the second game, and then we could win the third game. Or you lost the first game, win the second game, but then lose the third game. Now what happens if you go the other route? So say you lost the first game, lost the second game, but win the third game. Okay, it wasn't a complete shutout. Or like some people gotta say, you gotta take the L. So you lose the first game, lose the second game, and you lose the third game. So basically, you're going out for ice cream. All right? Yes, Bride, this is probability. Yes, we're doing this. Women love women. Some people are like that. Okay. All right. So, taking a look at this, these are the different outcomes that we have, okay? Either you going for total wins or you're going for total losses, and you got different combinations that's happening in between. So the first thing that it asks us is what's the total number of outcomes? So if we're taking a look at all of these, what is the total number of outcomes? Go ahead and put that into the chat. What's my total number of outcomes? Okay, so Bride is saying 7. Now don't forget, yes, Pog. Okay, don't forget we're also including the triple W's. Okay, so it's going to give us 8 of them. So we got 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8 outcomes. Now, what's the probability? Okay, so the total of them is 8. What's the probability of getting all wins? Put that into the chat. What will be the probability of getting all wins? Okay, we got 1/8. We got 1/8. Do we agree to get all wins? Okay, my dark circle of the moon is here. How are you? You got 1/8. All right. Okay, so there's one outcome out of the 8 that represents all your wins. So that will be 1 out of 8. Now here's another one. What's the probability of getting exactly 2 wins? So let me shrink a little bit so you can see how it's written. So what's the probability of getting exactly 2 wins? Okay, I know it's going to be something out of 8. So how many of these outcomes have exactly, that's the key words, 2 wins? Okay, so I got 3 out of 8, got 3 out of 8, got 3 out of 8. Okay, now, okay, so here, right here, we got exactly 2 wins. So that's 1. We got exactly 2 wins. That's 2. Right down here, we got exactly 2 wins. That's 3. So this will be 3 out of 8. So that's your probability. Okay? Nothing too crazy. Hey, Jonah. So nothing too crazy now. All right, so here's another situation. Ready? What's the probability at least 2 wins? And the key verbiage is at least 2 wins. Okay, so let's think about it. The probability of at least 2 wins. So my POG is saying 1/2. Hey, Lisa, how are you? Okay, so what is the probability of getting at least 2 wins? I'm doing all right. I'm doing all right. So yeah, tonight is not going to be super long. Okay, so we're just going to really hit on the probabilities of compound events. All right. Hey, how are you, Janice? Yeah, so this is something that you might want to pick up as well. Okay. So we have a 1/2, we have a 3/8 with a question mark, we have a 1/4. Okay. So now we need at least 2 wins. So if I take a look, one day I'll be famous and this will be nice and large, right? So we need at least 2 wins. So that means 2 or more wins. So yes, we got 1 right here. We got 1 right here. We got 1 right here. We got 3 of those. But we also can include the triple wins. Okay, we can include those 3, this one as well. So we got 1, 2, 3, 4. So we have 4 out of the 8. I'm going to put it down here. And 4 8s can be simplified to 1/2. Okay. All right. Okay, good. Yeah, so we can simplify that to 1/2. Now, for this last one, we want to know exactly 1 win. What's the probability of getting exactly 1 win? So let's take a look. exactly one win. And what's the probability of getting exactly one win? Put that into the chat. Okay. I got a couple of people. Both of them are saying 3/8. So exactly one win. So 1 W. All right. Yes, we got their algorithm. Welcome in. You're like, I didn't know how I got in here. All right. So we have exactly one win. So that's not that. That's not that. But it's this one. That's 1. It's this one. That's 2. It's this one. That's 3. So it's going to be 3 out of the total outcomes, which is 8. So 3 out of 8. All right. I know. All right. We love W. There you go. All right. So now that dealt with the wins and losses. Okay, so now we have another tree diagram, and you're probably like, oh gosh, why? But this time, it deals with looking at a tree diagram. So it's a complex event of flipping a coin. So that's what's happening here. We got our heads or our tails. Spinning a spinner with 5 sections. The sections is red, orange, yellow, green, or blue. Okay, and it's happening for both. One for the heads, one for the tails. And it's also flipping another coin, either heads or tails. Okay, so we need to construct the sample space, and then we're going to figure out our probabilities. So when first we get a heads, then we got red. We either can have a heads or we can have heads, red, tails. Okay? So then the next one is going to be heads, orange, heads, heads, orange, tails. There's going to be a pattern. There's going to be a flow. So heads, yellow, heads, heads, yellow, tails. Then we have heads, green, heads, heads, green, tails. Then heads, blue, heads, and heads, blue, tails. So now we're finished with the heads. This is my halfway mark here. So now we're going into the tails. So that means you have tails, red, heads, tails, red, tails. Tails, orange, heads, tails, orange, tails. Tails, yellow, heads, tails, yellow, tails. Try to do this 5 times fast today. Tails, green, heads, tails, green, tails. And lastly, tails, blue, heads, and tails, blue, tails. Okay. All right. So we can do all of this. How many total outcomes do I have? How many total outcomes? So what's going on? We're basically looking at the probabilities of 3 events. One coin is being flipped to heads or tails. Then there is 5 different colors on a spinner. And then another coin is being flipped heads or tails. Okay. So I'm seeing 20, 20, 20, 20, a 21, a 20. Okay. So it is going to be, okay, switched over, good. So it is going to be 20 outcomes. Okay, so we have a total of 20 different possible outcomes. Now, what's the probability? I'm just going to leave this up here. I can do the writing off to the side. What's the probability of getting a red? Okay, we know it's something out of 20. What's the probability of getting a red? Okay. So I got a 4, I got a 3, I got a 1/5, I got a 4. I think V is trying to say 4 out of 20. Hey, Ashley, thanks for coming in. Or is it 4 out of 2? Okay. So how many reds? Okay. Okay. 6%, you don't know? Okay, it's 4 out of 20. Okay. All right. So you guys, with the 4 out of 20s, that's correct. Because the first two dealt with the reds with the head. Down here deals with the reds with the tails. So we have a total of 4 out of 20. But 4 20ths can be reduced. And I think my friend Pug has done it. 4 20ths. Okay. Totally missed the top. Yes, we got our 1/5. Good. Good. We got our 1/5, 1/5, 1/5. Yes. All right. So the probability of getting a red is going to be 1/5. Now, what's the probability of exactly one head? What's the probability of getting exactly one head? Think about it. To get exactly one head. Okay, Joe's saying 50%. Pog's saying 1/2. Hey, Sophia. Okay. Can I get one more comment? I like to do things in threes. Oh, thanks for the follow. Okay. 1/2, yes. Because think about it. There is, good evening, Two Scoops. Okay, if there's 20 of these options, and I said right here is going to be halfway, right? So we're doing half heads and half tails, so half of 20, that's going to give you 10. So 10 out of 20, that is going to give you 1/2. The probability is going to be 1/2. Okay, from the last column. Exactly. Okay, you can take a look at the last column. You can count as many H's that you want. You can do that. All right. Or since it already starts off with one coin that's heads, the other part is tails, you know half of your data is definitely going to have heads. Okay. All right. So the probability, at least one head. Okay. At least. So at least means you could have one or more. Okay. One or more. So how many of them? How many out of 20 has at least one head? So I got 15 out of 20, 15 out of 20, and I got 3/4. 15 out of 20 or 3/4. Okay, any others? Any other brave souls? Okay, hey Sid. All right, yes. So there's going to be 15 of them, at least one head. So it's basically the 10 that we got from here. And then you got your 11. Here's another one, 12, 13, 14, 15. So 15 out of 20 reduced will give us our 3/4 because you reduced that by 5. Awesome. All right, and the last one for this one, the probability of 2 heads. What's the probability of 2 heads? So the probability of 2 heads. Try to do another recount, Lisa. I think there's a couple that you're missing. Okay, so Joe got 5/20. Pog is 1/4. 1/4. We got 1/4. There you go, Lisa. We got 5/20. Good. So 5/20. So it has 2 heads. So we got this one up here. That's 1. This one here, that's 2. This one here is 3. Then we got 4. And here's 5. There's going to be none down here because most of them are going to be the first number, the first side that comes up is my tails. Okay, so 5/20, that gives me 1/4. All right, you guys are awesome at this. You don't need this. All right, so while I'm about to go to the next part, because I have about 5 more problems. Because as I said, this is going to be like a short one, okay? Because I really just want to make sure you guys got the complex events. And it seems like you guys are gripping this real easily. Go ahead and just do a little mat tap for me. Everything's pretty much situated. And if you know of anyone, and I do mean anyone, I know most of you guys are going on spring break right now. I know we're on spring break from Maryland, and there's a couple other states on the East Coast that's on spring break. And, you know, they're just enjoying the outside, and I'm still here doing math. But if you do know of anyone whose teacher felt bold enough to give their students a packet for spring break, yeah, I actually have a couple students, and they need some assistance with their packets. Please bring them my way, because I do have a couple openings because of the spring break, but I do have a few students that are doing spring break packets for math, just to get you ready for the testing, because we know next month, as soon as we come back from Easter break, it's always getting ready for those state assessments. Yes, aren't you excited? No. But at least, you know, some schools will get out earlier, but I know there were some schools they'll just have you do testing in the morning, and then in the afternoon you would have to go back to class. I always found that very hilarious, thinking that students are actually going to be doing work when they get back after testing. Yeah, good luck with that. So teachers always have some kind of fun activities or just want to do something that's a little bit creative around that time of year. So yes, May is generally testing, especially those people that are doing AP testing, they're doing state assessments, SATs. It's always big to do around this time. All right, so if you need assistance, just let me know. Okay, I'm in math too, so no tests. Okay, good, good. So what we're gonna do, oh, where'd my other pen go? I had another pen, I don't know where it disappeared to, but that's okay. All right, so now we have class elections. Try to minimize it as best I can, so I'll just read it. So we have class elections are being held at Bringington High School for the upcoming school year. Ben and Kylie are running for class president, and Mike, Emma, and Adeline are running for vice president. So we want to create a tree diagram that demonstrates the total number of possible outcomes. So that's the first part. So first things that we want to kind of take a look at. One, we want to figure out who is going to be my president and my vice presidents. So if we look, first two numbers we can have is Ben, and then the other one is Kylie. So with Ben, we're going to have what? 3 options? 1, 2, 3. And the same with Kylie. 1, 2, 3. All right, so we have M for Mike, E for Emma, and A for Adeline. And the same thing is happening with Kylie. So how many outcomes are we going to have? How many outcomes should we have? So how many total outcomes should we have? Okay, Lisa's saying 6. Anyone agree? Okay. Because just like what we did earlier, okay, so 12 scoops the same, we're going to have 12. 2 scoops the same, we're going to have 12. Okay, so let's take a look. We could have Ben, then Mike. We could have Ben, then Emma. Then we can have Ben and Adeline. Or we can have Kylie and Mike, Kylie and Emma, or Kylie and Adeline. So if we take a look, there we go. Hey, Rayon. All right. We take a look. We got 1, 2, 3, 4, 5, 6 different outcomes. Okay. So we have a total of 6 outcomes. Okay, so we're going to have a total of 6 outcomes. So now for the next part, it asks, what is the probability that the president and vice president are girls? So we know it's going to be out of our total of 6. Okay, not to put labels on everything. Okay, but if we could, just putting it out there, if we could go by name, what do you think the probability? How many outcomes for both the probability? How many outcomes for both the president and the vice president? If they went traditional ways, okay, what do we think? I got 1/3. I got 1/3. Okay. Okay, anyone else? Okay, we got 2/3. All right. So right away, if I'm looking for the president, so I'm not looking at the top 3 that's happening up here. I'm going to focus my attention on this bottom section with Kylie. So M is representing Mike. E is representing Emma. So that's a girl, if it is traditional. Then we have Adeline. Usually that's traditionally a girl. So we have 2 out of the total of 6 options. Okay? So we have 2 out of 6. Reduced, that's going to be 1/3. Because I can reduce the 2 and the 6 by 2. So my probability is going to give me that 1/3. That is the number of outcomes that it's not possible that the probability of the certain outcome is greater. Let me read this again. That is number of outcomes. It is not possible that the probability of a certain outcome is greater. Or have they specified it all equal? Oh, they specify it all equal. Okay, I get it now. Okay, yes. So right now we're just going based off all equal. Like everyone has like an equal chance. Okay. Good eye. All right. And here we go with the last one for the evening. They always have something with food or ice cream that's involved. All right. So if we take a look at this one. So we got an ice cream shop offers options according to the table below. So you either have vanilla or strawberry ice cream. You can have fudge, marshmallow, or butterscotch topping. Or you can have rainbow or cinnamon sprinkles. Okay? So if we were to make our diagram, like think about how many different options could we have? How many different outcomes could I have? So if we have our vanilla, maybe not want to put it that high because I got to put everything else up. So if we have our vanilla and then we have our strawberry, we got 1, 2, 3, and 1, 2, 3. So this is giving us our fudge, marshmallow, butterscotch. And then each of these will have your sprinkles, either rainbow or cinnamon, rainbow or cinnamon, rainbow or cinnamon. Okay, so we're looking at 12 different options. Okay, one way of you can do it, because there is something that we can do without constantly have to draw these lovely little diagrams. Okay, if I notice that there is 2 different types of ice cream, there is 3 different toppings, and there's 2 different sprinkles. Couldn't I just multiply these 3 together? 2 times 3 gives me 6. 6 times 2 gives me 12. All right. Right, there we go. All right, so we have 12. My total is 12. So how many different possible ice creams is 12? Does anybody remember what that process was called? It began with an F. Okay. If not, I got you. Okay. So if choices were made at random, what's the probability of getting a strawberry ice cream with cinnamon sprinkles? Combination Yes, but it had like a certain flair to it. Yes, but it had like a certain flair to it. It is a form of combination, but there was like a principle that's attached to it. And it began with an F. So it is combination, but it had like a certain principle that showed that all you're doing is just multiplying to get your totals instead of constantly doing these. So for you to get vanilla with cinnamon sprinkles, what is my probability for that? So I'm going to write the probability vanilla cinnamon. Okay, so Lisa's saying 3 out of 12, which is reduced to 1/4. Okay, we got our 12 options. Vanilla cinnamon, that's 1. Vanilla cinnamon, that's 2. Vanilla cinnamon, that's 3. So 3 out of 12 can be reduced to 1/4. So the probability of getting, it's strawberry. What am I saying? Oh, strawberry. Ooh, my fault. Okay, strawberry, cinnamon, that's 1, that's 2, that's 3. So 3 12s. Okay. Thank you. Okay. Strawberries, squeeze it in there. Cinnamon. Okay. So it's going to be 3 out of 12, which gives me 1/4. All right. So instead of basically doing this multiplication, or instead of doing the whole diagram, we can actually do this multiplication. And that form of multiplication is called the foundational counting principle. Okay? You're like, what? Yes. Okay, the foundational counting principle. So we are actually going to, we can just do it. And that'll be like one less thing I have to do. And then for tomorrow, I can do the mutual, independent, and dependent. So we can get that before we go into measures of central tendency. Okay, looking at those different types of graphs. So yeah, going a little bit harder on that probability because sometimes it will show up on those assessments, and just want to kind of get you ready for that next step. So, fundamental counting principle, very similar to like we said. All we're basically doing is trying to find the total number of outcomes in each of these sample spaces. So if I'm looking at rolling 2 6-sided dice, all right, so I know that I have 1 dice, and the probability of rolling 1 dice is going to be, so I'm going to have dice, die, and die. Okay? The probability of rolling 1 die, okay, the probability of getting any kind of number is going to give me 6 different options. Okay? Because it has 6 sides. The probability of me getting the other dice is also going to be 6 sides. So 6 different options. You're not going to add them. Okay? You're not going to add them. You're multiplying. Okay? So you're multiplying to see what you got. So the possible sample space that you have is going to be 36. So anytime they give you like how many times can you get a 2? You roll 2 dice. What's the probability of you getting a 2? So the probability of you getting a 2 would be 1 out of 6 times 1 out of 6. So that will be 1 out of 36. Okay? So it's not going to be addition. It's going to be multiplication. All right? We're understanding ourselves here. All right? So tossing 3 coins. All right? We're understanding ourselves here. All right? So tossing 3 coins. Remember, for coins, you're either going to have a heads or a tails. So the probability for the first coin is going to be 1 out of 2. So it's going to be 2 sides. The probability of the second coin is going to be 2. That means the probability of the third coin is going to be out of 2. So 2 times 2 times 2, or 2 cubed, that will give me 8. Oh. Oh no, all of a sudden my screen just went blank. Okay. I'm not sure if I went blank for 5 seconds, but I just looked on my laptop and I was like, what's happening? Where did everyone go? Okay. So the probability of tossing 3 coins, you're just looking at the sample space. So there's 2 sides for one coin, 2 sides for another coin, 2 sides for the third coin. 2 times 2 times 2 gives me 8. Let me kind of box these bad boys. All right. So now this is an interesting question. Believe it or not, I pulled this from an SAT. Now, if you don't understand what a consonant is and what a vowel is, you're going to have problems answering this question, okay? This is why I do not, probability is not my love, because it's very subjective in a way, okay? Unless you know the terminology because there are some people, and I mentioned this before, that they don't do gambling. So they don't know what a number cube or a dice is. There's a lot of people that don't know what a 52 deck of cards look like. They don't know what a face card is. They don't know any of that stuff. But when we think of it, first of all, there is 26 letters. I'm going to put it right here. So there's 26 letters in the alphabet. Okay, it's 26 letters. Now, of those 26 letters, we have our vowels. So we have A, we have E, we have I, O, and U. And we're not doing that whole sometimes Y thing, okay? So legit, right now, you have those 5 vowels, okay? So for the vowels, you have 5 options. So if we have a total of 26 letters, how many are going to be consonants? Okay. How many are going to be consonants? There's a total of 26 letters. 5 of them are going to be vowels. How many are going to be consonants? There we go. There we go. Hey, King Cash. All right. So there we go. So that means there's going to be 21. So in order for us to figure our sample space out, we multiply 21 times 5. And 21 times 5 will give me what? Okay, so it's 26 minus 5. That's how we got our 21. Okay, so what's 21 times 5? Okay, 2 scoops of chocolate says 105. Do we agree? 2 scoops of chocolate. Okay. Is it Lena? Or Anna Lana? Lana's saying 105 as well. Okay? Okay. All right, so good. So that means we have 105 possible, okay, possible ways, okay, for my sample space. Now, how about this one? Rolling 2 dice. So we're gonna make it a little bit bigger. All right, so rolling 2 dice and tossing 2 coins. All right, so let's think about it. We know about the 2 dice because we just did that not too long ago. All right, we just did that. So yes, it will give me 36. So that takes care of the 2 dice. Tossing 2 coins. We did 3, but what would 2 coins be? Okay, King Cash is telling me 4. Good, 4. Nice. So now all we have to do is multiply 36 times 4. So 36 and times 4, how many outcomes do we have? Okay, so 2 scoops is saying 144. Do we agree? Thumbs up, thumbs down, yes or no? Okay, good. Okay, so that's all we have to do is just multiply that 36 and that 4. So we know there's going to be 6 options for the first die, 6 options for the second die. You multiply the 6 times 6, that's where the 36 came from. To toss in with the 2 coins, that means you have 2 options with 1 coin, 2 options with another coin. Heads and tails, heads and tails. Multiply 2 times 2, that's where this 4 came from. So now to look at how many possible outcomes, because that's what we're looking for. We want to look at our sample. We're looking at our sample space. Okay, you're getting it. Yes, of course you're getting it. All right, now this comes up quite often. If it's not this, it's the other one that's on my other page. Choosing a 4-digit PIN. So a PIN is a personal identification number. So when we're choosing our PINs, we have options from 0 to 9. Okay? So if we're trying to get a PIN, we're getting from numbers from 0 to 9. How many numbers is that? I know, I don't want to insult your intelligence, but you know, just entertain me. Just entertain me. Okay? How many numbers is from 0 to 9? Okay, King Cash is saying 10. Okay, do we agree? How many? Okay, so got 2 scoops that's agreeing with you. All right, I know for sure someone's thinking 9. Okay, but we're including the 0. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits. Okay, so that's 10 digits. So if we're looking at a 4-digit PIN, we're assuming that we can reuse digits. We're assuming that we can do that. We can reuse digits, right? So it's not, okay, I used a 0. Okay, I can't use that 0 again. All right, I used a 4. Oh, can't use the 4 again. No. The 4 is reusable. The 7 is reusable. Good, Pog. So basically, we're saying for the first digit, we're saying for the first digit, for the second digit, the third digit, and the fourth digit. We have an option of 10 digits for the first. We have an option of 10 digits for the second. Same thing for the third, and same thing for the fourth. Okay, so we're looking at 10 to the fourth power. Okay, it's 10 times 10 times 10 times 10. 10 times 10 gives me 100. 100 times 100 gives me 10,000 possibilities. Okay, 10,000 possible outcomes. Okay, so it's not going to be 10 times 4. It's going to be, I have 10 digits for the first, I have 10 possible digits for the second number, 10 possible digits for the third, and 10 possible digits for the fourth. So it'll be 10 times 10 times 10 times 10. Okay. All right. So this is how many possible outcomes you will experience. All right. So for number 6, a sandwich with ham, turkey, or roast beef. A sandwich with ham, turkey, or roast beef, Swiss or provolone cheese, and mustard or mayo. So for the meat and for the condiment, you either have mustard or mayo. Okay? How many possibilities? How many possible outcomes? So what do you think? How many possible outcomes? That put you guys to sleep? Are you mesmerized by the music in the background? Or are we just confused? Remember, question marks are answers too. I accept question marks as well. Okay. Can we set up the tree? You can set up the tree, but you don't have to. Hey, Tina K. You have 3 different types of meats. You have 2 different types of cheeses. And you have 2 different types of condiments. How many outcomes? There we go. There it is. Yeah. I mean, you can do your tree diagram if you want, but all you have to do is multiply 3 times 2, which gives me 6. 6 times 2 gives us 12. That's it. Nothing too crazy. Okay? Nothing too weird. All right, so before we go into the next part, go ahead, let's tap it up. I know, it seems like everyone is leaving me. Maybe because we're on vacation, or we're just like, don't know when I'm going to go on, or you don't need me anymore. That's fine. But I'll be here like a parent, just sitting here waiting for my child to call me from the home. I'm so pathetic. Anyway, so we're almost done. We basically have 7 through 11, and then, well, actually 11 we might not have to do. 11 is sort of kind of some busy work, and we don't really want to have busy work. All right. So now, for the next one, we got the number of possible outcomes. If we have 2 quarters. The next one, we got the number of possible outcomes. If we have 2 quarters, 4 dimes, and 1 nickel are tossed. Okay? What are my possible outcomes? Remember, I'm just dealing with the coins because each coin has what? Each coin has a head and they have a tail. Okay, so let me put it to you this way. So for the quarters, you have 2 options. You have a head or a tail. And there are 2 quarters. Okay, so that takes you 2 times 2. For your dimes, you also have the same option. Oops, I was thinking 4, writing 2. Okay. Each dime has 2 options, either a head or a tail. Then for the nickel, you have its 2 options. So we're looking at 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay? So we can say 2 times 2 is 4. We got 4 times 4, which is 16. And then you have 16 times 8. Or, since there are 7, so it could be 2 to the 7th power. So what's 2 to the 7th power? What do we get? Hey, Lester. It's been a minute. How are you? Okay, and Dolores. Hello, Dolores. Okay, so 2 to the 7th power. Oh, San Leon, how are you? Okay, 2 to the 7th power, what are we getting? 2 times 2 gives me 4. 2 times 2 gives me 4, so that's 16. Okay. Or you can do 10 times 2 times 2, that gives me 8. And 2 times 2 times 2, that gives me 8. And 8 times 8 gives me 64. And then 64 times 2, that might help us out. There you go. Thank you, Dolores. So that will give us 128 different outcomes that can occur when tossing that many coins. Okay, so we're just basically looking at our sample space. All right, so here's another one that's a little more fun. So we have a license plate that has 3 numbers from 0 to 9, okay, and 2 letters. Okay, so we talked about the 0 to 9. We talked about that 0 to 9. So we know the license plate from 0 to 9, that's 10 digits. But there is 3 numbers. So that means there's 10 options there, there's 10 options there, and there's 10 options there. This is basically the first number. Okay, this is the second number. and this is the third number. Because remember, you can reuse those digits. It's not like you just use one digit and then you toss it away, okay? But then they're saying that there's 2 letters. So we know with the letters, there's 26 letters in the alphabet. So we got 26, and then we got 26. Okay, so this is that letter 1, and this is my second letter, my letter 2. So now, doing all of this, we know that 10 to the third power, that's going to be 1,000. So we got 1,000 right here. But 26 times 26, that will give me 676. All right. So if we're multiplying our 1,000 times that 676, we'll get 676,000. So that's how many possible outcomes there are for that license plate. Okay. Oh, good. Exponent expressions. Awesome. Okay. So if we take a look at the next one, let's see if I can fit it all in there. Okay. So now they want us to find the number of possible 9-digit social security number if the digits may be repeated. Okay, I think we have a pretty good idea about that. Okay, so we have a 9-digit, okay, social security number. So how many possibilities? So if we can write it as an exponent, that will make life way easier. So that means the first digit, you have 10 possibilities. Okay, and they said that the digits may be repeated. So that means this is for the first digit. That means for the second digit, we also have 10 options. Okay, same for the third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth. So if I can write this as an exponent, it'll be 10 to the what power? There you go, Dolores. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be 10 to the 9th power. And we all know that's going to be a crazy, insane number. I mean, I love how my students think that a 3-digit number is like, wow, it's a big number. I'm like, wait until you get to high school. You're going to be dealing with all kinds of craziness. Okay? So, if we're saying a license plate with 3 letters, all we're doing is just multiplying the 26 to itself 3 times. And we don't have to solve, so it's just going to be, let's keep it as exponents. So it'll be 26 to the 3rd power. Okay? License plates with 4-digit numbers, I think we're beating a dead horse right now. Let's just let it die. Right? Why have you sit here and be bored? All right? So, and that's the one thing, like they always have some kind of question like number 8, with the license plate and the numbers. They always have something like this on the SAT. Or sometimes you'll see it might be the pin, like how they mentioned it over here about the pin. So a lot of times they'll just say, you know, you got 4-digit pin and you can't repeat the numbers. If they said you cannot repeat the numbers, that means the first number is going to be a 10, but the second number is going to be a 9, then an 8, then a 7, then a 6, and so forth. Okay, so say we can't repeat, so that's when you're really going to have to sit down and read the directions. Alrighty? Okay, so I'm going to pause on this. I think we did plenty. All right, so we worked a little bit with those compound, let me twist it. Okay, with the compound events. Okay, trying to figure out what our space is going to be, what our sample space is going to be, and then try to figure out what our probabilities are, as well as worked on the fundamental counting principle. So we just want to know how many options, how many outcomes we're going to have. All right, so I think next time we meet, which will be tomorrow night, and it's probably going to be 8 o'clock tomorrow because a lot of my later kids they're done or they're in spring break. So yeah, I'm just sitting here twiddling my thumbs. So that's why I decided to come on at 8 o'clock instead of 9:30, like some crazy amount of time. But if anything, we'll continue on and we'll constantly keep looking at stuff. Yeah, so have a good night. Have fun scrolling. Okay, watch what you're scrolling. But if you do like the format of my book, hey, I'm on to the next book. All my books are starting to fill up really quickly. So this is a book that I actually created. It's on my website. If you want to buy it through Amazon for right now, trust me, I'm working on getting my own, publishing. So I'm trying to be a self-publisher. And if anything, it always has a lot of different reviews and different options that kind of help you out. If multiplication isn't your thing, I got the factors from 1 to 200. All right, we got our integers. We have our order of operations, the products of exponents, and just anything to help you out with math, just as a resource. So we have like Pythagorean's theorem, SOHCAHTOA, we got our inverses, we're talking about volumes and surface area. Yes. Can we learn about this? We're talking about volumes and surface area. Yes. Can we learn about slope? Yes, you can. Actually, if you want, because that's the next thing I'm going to say, if you're interested into this, you guys can also help me out a little bit. So if anything, you guys can go to my YouTube channel. I know I already did slope, but I'm more than willing to do it again. But I just wanted to kind of get the probabilities out the way. But if you want to subscribe to my YouTube channel, it's free. Okay, I have all of my YouTube lives all on my YouTube channel. So all of my, not my YouTube lives, all my TikTok lives on my YouTube channel. And if you do have a moment, if you can go to Google and just type in ACG Math Tutoring, if you can do a review for me, I would greatly appreciate it. It doesn't matter where in the world you are. This is also considering, tutoring. So how am I doing it? Is it helping you? Is it, clarifying the options? Please just write like a short little review. That'll be awesome. And then I'm still working on my live schedule. So tomorrow, which is Tuesday, I will be on at 8 p.m. Yes, you need that book? Awesome. It is ready for sale. Okay. You can just go to my profile. Just click on my picture, go into my profile, go to my website. And then it says the Ultimate Math Notebook. Okay. So I have one just like this. The last one that we finished looks like this, and there is a third one, which I don't have just yet, but I also have one for my 4th through 6th graders. So theirs is kind of a little bit different with the math because I'm trying to make sure that they keep everything lined together. So that's why I did the math tiles on this one. And then, of course, they also have a lot of review sections about fractions, about place values, decimal operations, okay, dividing, order of operations, conversion charts, that's also in there as well as like brain breaks, because we all need a little brain break, just a little puzzles, just to kind of help us refocus a little bit, just to kind of break up the monotony, right? So these are for 7th through adults. This one is from 4th through 6th. So yes, you can order those and they'll come straight to you from Amazon. All right. So if there is anything else, you have some interesting takes on some things, again, you can go onto my YouTube channel, take a look at some of the videos. But I know once June hits, I'm probably going to be starting all over again. I'm thinking about doing something to get people ready before you take a class in a community college, because I feel like a lot of the classes goes way too fast, and there are some things that you need to know as a prerequisite before you can even start those classes. So I'm thinking about doing something like that starting in June, because as soon as Easter is over, my schedule is going to get completely obliterated. It's just going to blow up. And especially since in Baltimore City, they got rid of the tutoring programs and some of the after school resources. So a lot of parents are like, I don't know where to go. I don't know where to go. I don't know what to do. So yeah, it's going to be nuts. But anywho, if you're interested in this, or if you have any kind of questions, or even if you're interested in like, you know what, Audrey, I would love to learn how to do math before I go into community college, this will be a perfect thing for you. All right. So I'm going to sign off. Thank you so much for the taps. I really appreciate that. Thank you so much for the follow. Because if you know someone that is thinking about getting back to school, they need help with the ACCUPLACER. They need help with their math in the ASVAB. They also need some help with the algebra piece for the TEAS test. If you know anyone, please share my information. Don't be selfish, keeping it to yourself. Okay, share my information to people. Let them put it out there. And if anything, I do have courses as well that can help out with the whole source, but all that is inside of my website. Okay. Yeah, I did. She's like, did I miss it? I'm like, yeah. It's not your fault. I just went early because I had a cancellation and I am tired. But if anything, I will try to upload it tonight as best I can. I know. It's like I just tried to just put it up as best I can because I need to get some regular sleep because, yeah, my health is not doing all too peachy keen. So I definitely have to make some changes. Also, here's some people that you want to follow. If you're thinking about doing nursing, go to a Blessed RN. If it's a T-test, ASVAB, GED, and you need someone like during the day, like roughly around 1 p.m. Eastern, 2 p.m. Eastern Standard Time, 1 p.m. Central Time, meet up with my friend Evelyn from Impact Math 19. She is fabulous. As well as if you know someone that needs help with chemistry, go to Professor TK. She knows her stuff. I mean, I sit there and I'm blown away. And then if you want to learn a different way of getting in touch with math and learning the basic concepts, and maybe if you want to teach your child or someone how to understand adding, subtracting, multiplying, and she's working on dividing, meet my girl Lynette, okay, Learning with Lynette. She is amazing with the abacus. If you want to know what abacus is, look, if you type the word math in the text message, this little symbol always comes up with the beads. Okay, it's been around for centuries, and she's probably mainstreaming it, and I'm really proud of her for doing that. All right, so like I always say, do you need to be, what days do I need to be on the website? What days do you need to be on the website? It's every day. It's on demand. You can just go. You don't have to have a certain day. It's like every time you sign on, and you can just go ahead and do work. Yep. So you don't have to wait for me. It's just when you get stuck, you're like, okay, I need to make an appointment so we can break concepts down. Okay, that's what we will do. Okay. All right. Hey, Tilted, hello. All right, everyone. Okay, so if you need me, if you have any questions, please do not hesitate. Anything for you need me. If you have any questions, please do not hesitate. Anything for TSI? Is that the one in New York? Hey, y'all. Hey. Because if it is the algebra piece of it, I can help you with that. Okay? Because a lot of people have it in different sites. Okay? All right. So, message me. Go to the website. If you want to do a little quick meet and greet, we can definitely do that. If you want to talk further about how I can help, and if it's not me, I'm in Texas. All right. Yeah, I actually have a few students in Texas as well. So if anything, Tilted Halo, definitely reach out to me. Okay, message me. If you want to, you can go to my website and just do like a quick fill up of the contact page, and then we'll just do a phone call and just figure out how I can help you. Okay? All right. Okay. All right. Take care. Hello, Michael. Yep, I'm signing off. So hopefully everyone's going to have a great night, afternoon, morning, and I will talk with you soon. Okay? Take care now. Bye.